Introduction to Operations Research. Number 1. Introduction and meaning. The term OR was first used by McCloskey and Trephan in 1940. In military contexts, new scientific methodology was used during World War II. For solving strategic and technical problems, such methods were used. Such a new approach used in the scientific study of the operations of the system was known as operations research. We will abbreviate it as OR. OR was used as one of the subjects in the universities during the year 1950. Then after, it becomes very much useful in economics, management, public administration, engineering and in many more branches. In 1950, OR Society of America came into existence. International Federation of OR Societies were established in 1957. In India, at Regional Research Laboratory at Hyderabad, an unit of OR was opened in 1949. During the same time, Defence Science Laboratory was started, another group to handle the problems regarding stores, purchase and planning. Indian Statistical Institute, Calcutta used the application of OR methods in national planning and survey in 1957. In India, Professor Mahalanobis formulated the second 5-year plan with the help of OR techniques. The linear programming techniques of OR become most popular in India. OR has been described by various persons as follows. Number 1. OR is a scientific method of providing executives departments with a quantitative basis for decision under their control by P.M. Morse and G.E. Kimball. Second, OR is a scientific approach to problem solving for executive management by H.M. Wagner. Third, OR is a scientific knowledge through interdisciplinary team effort for the purpose of determining the best utilization of limited resources by H.A. Taha. Let us see number 2 opportunities of OR. 1. The decision maker can get a solution to his problem with the help of models of OR. Number 2. A manager can determine the best decision for the organization as a whole by considering all necessary variables associated with the decision using OR approach. Number 3. OR approach becomes useful to a decision maker to solve a complex problem which may not be possible to solve by any traditional methods. Number 4. Using OR approach, a simulation, a decision maker can examine a situation from different angles and different conditions associated to the real problem. Let us see now applications of OR. OR techniques are used in many different areas of research in defense, government, industry, etc. Some of the applications are described as below. Number 1. Finance, budgeting and investment, in cash flow analysis, in dividend policies, in investment portfolios. Number 2. Purchasing, procurement and exploration, in deciding rules for buying and supplies in stable or varying prices, to determine quantities and timing to purchase and replacement policies. Number 3. Marketing, for product selection, timing and competitive actions, in advertising media with respect to cost and time for. Number 4. Production management, to determine location and size of warehouses, distribution centers and retail outlets, to determine the transport schedule, in production scheduling and sequencing, in maintenance policies and preventive maintenance. Number 5. Research and development, to determine the area of research and development to determine time cost trade-off to coordinate multiple research projects. Number 6. LIC. In the cases of policies with profits, to determine best way of distributing profit. Let us see limitations of OR. There are certain problems can be solved, least cost and less sophisticated approaches available, and decision makers may have to solve such problems only once. In such situation, use by complex OR model becomes too expensive. Number 2. Sometimes OR users become too much enamored with the model they have built and forget the fact that the model does not represent the real world problem. Number 3. Sometimes the basic data are subject to the frequent changes. In such cases, modification of OR models becomes very much costly. Number 4. Many OR models cannot be solved without using the computer and becomes difficult to explain the outcomes of the models. Number 5. Magnitude of computation and lack of consideration for non-quantifiable factors. Let us see number 5, modeling in OR. A model in OR is a simplified representation of an actual object or situation. It shows the relationships and interrelationships of action and reaction in terms of cause and effects. A. Object of modeling. The objective of modeling is to provide a means for analyzing the behavior of system to improve its performance. B. Main characteristics of a good model. Number 1. It should be capable of taking into account new formulations without affecting in its trend. Number 2. Assumptions involved in the model should be small possible. Number 3. It should be simple and coherent. Number 4. Numbers of variables involved in the model should be less. 5. It should be open to parametric type of treatment. Number 6. It should not take much time in its construction for a given problems. C. Limitations of a model. Number 1. Model should just not be considered as absolute in any sense. It is just an attempt to understand the operation. Number 2. Validity of any model can only be verified by carrying the experiment and relevant data characteristics. D. Classification of models. Several types of models are used in the area of business or industrial activity. Number 1. Models by degree of abstraction. These models are based on the past data of the problems under consideration. Second, descriptive model. It simply describes some aspects of situation based on observation survey or other available data. Number 3, predictive model. Such models make prediction regarding certain events. Number 4, deterministic model. Such models assume conditions of complete certainty and perfect knowledge. Number 5, stochastic model. By such model, it is possible to forecast a pattern of events based on which managerial decisions can be made. It is known as probabilistic model also. Number 6, specific model. A model presents a system at some specific time is known as a specific model. Number 7, static model. If time factor is not considered in the model is called a static model. 8, dynamic model. When a time is considered as one of the important variables and admit the impact of changes generated by time. 9th, mathematical and symbolical model. They are most abstract in nature. They employ a set of mathematical symbols to represent the relation between the components of real system. These models are most general and precise. Number 10, simulation and heuristic model. These models have a specific mathematical structure and cannot be solved by purely using the tools and techniques of mathematics. These models are used to explore alternative strategies were overlooked previously. Heuristic models do not claim to find the best solution to the problem. E. General method for solving model. Usually the following three types of methods are used to solve OR models. Number 1. Analytic method. The tools of classical mathematics like calculus, finite differences, etc. are used for solving OR models. Solutions of various inventory models are obtained by this method. This method is also known as deductive methods. Number 2. Numerical method. When classical methods fail due to complexity of constraints or variables, then this method is adopted. This method is an iterative method or a trial and error method. In this method, iteration starts with a trial solution and a set of rules for improving it. The trial solution is then replaced by the improved solution, and the process is replaced until either no further improvement is possible or the cost of further calculation cannot be justified. Number 3. Monte Carlo method. This method involves the use of probability and concept of sampling theory. The steps associated with this method are as follows. A. Make sample observation and determine the probability distribution for the variables of intervals or the given model. B. Convert the probability distribution to cumulative distribution. C. Select a sequence of random numbers with the help of random number tables. D. With the help of the random numbers generated in the above steps, determine the sequence of values of variables of interest. E. Fit an appropriate standard mathematical function to the values obtained in D. 6. Brief outlines of OR models. A brief outline of some OR models is given below. Number 1. Distribution models. Distribution models are concerned with the allocation of available resources so as to maximize profit or minimize loss subject to prescribed restrictions. Mathematical programming techniques are used to solve such models. The mathematical programming may be linear or nonlinear. Second, inventory models. These models are concerned with the determination of economic order quantity and production intervals, considering the factors like demand per unit time, shortage cost, held up cost, cost of ordering, etc. Number 3. Queuing models. The problem related to queue of customer at a service counter or vehicles coming for service at a service station, etc. Such models are used. The points like overage time spent in a queue, overage service time, traffic intensity are concerned in these models. Number 4. Competitive strategy models or game theory models. These models are used to determine the strategy of decision maker under competition or conflict. Number 5. Network models. These models are useful in large projects involving complexities and interdependencies of activities, project evaluation and review technique we call PERT, and critical path method we call CPM are used for planning, scheduling and controlling the project. Number 6. Job sequencing models. These models are used to determine the best sequence of patterning actions or jobs that optimize the efficiency measure of performance of the system. 7. Replacement models. These models determine the optimum replacement policy where some items or machinery need to replacement by a new one. individual or a group replacement policy can be used in case of equipment that fails completely and instantaneously. 7. Mathematical modeling or formulation in linear programming problem. A linear programming, it is a technique for determining an optimum schedule of independent activities in the view of available resources. Here a1x1 plus a2x2 plus a3x3 plus up to an xn, where a1, a2, an are constants and x1, x2, x3 up to xn are variables. B. Objective function, a linear function of variables which is to be maximized or minimized is called objective function. C. Constraints, a given set of equations and inequalities based on the given variables involved in the problem is called constraints or restrictions. D. General procedure for mathematical formulation of LPP. Number 1. Study the given situation to find the key decision to be made. Second, identify the variables involved and denote them by symbols xj, where j takes value 1, 2, 3, so on. Number 3, state the feasible alternatives which are generally xj greater than or equal to 0 for all j. Number 4, identify the constraints involved in the problem and express them as a linear equation or inequality. Number 5, identify the objective function and express it as a linear function of the decision variable. 8. Example 1 for production allocation problem. A manufacturing company has 4 machines, centers, machining, grinding, assembling and painting to produce 4 products A, B, C and D. The available numbers of hours per month in each of their centers are 250, 80, 650 and 400 hours respectively. The numbers of hours required by each product in each of these centers are given below. Let us see in this slide. We have given the 4 products A, B, C, D and first column denotes the different types: machining, grinding, assembling and painting. The values for machining for the 4 products A, B, C, D are 1, 1.5, 3, 1. Similarly, for grinding it is 2, 2, 5 and 2. For assembling 5, 4, 6, 6 and painting 2, 3, 3 and 3. The profit contribution for the product A, B, C and D is rupees 20, rupees 50, rupees 25 and rupees 40 respectively. Assuming there is enough demand for these products, how much of each product the company manufactures to maximize the total profit? Solution. The given data we summarized as follows. Now, in this table we write the profit due to the different types of product and available times for different types: machining, grinding, assembling and painting in the last row and the last column. Using this slide, let us prepare the model for the given problem. Step 1. Here we have to determine the number of each types of product to be produced per month. Let x1 be the number of units of the product type A, x2 be the number of units of the product type B, x3 be the number of units of the product type C and x4 be the number of units of the product type D per month. Step 2. Feasible alternatives are xi greater than or equal to 0 for I equal to 1, 2, 3 and 4. Step 3. Objective function. Since the profit of type A is rupees 20 per product, then 20 into x1 will be the profit on x1 units by type A. Similarly, 30 x2 will be the profit on x2 units by type B. 25 x3 will be the profit on x3 units by type C, and 40 x4 will be the profit on x4 units by type D. Hence, the objective function becomes maximize profit Z equal to 20 x1 plus 30 x2 plus 25 x3 plus 40 x4. Step number 4. Construction of constraint. For 1 unit of product type A, machining require 1 hour of time. So, for x1 units of type A, time required for machine is 1 into x1. Similarly, the time for machining for x2 units by type B becomes 1.5 into x2, and for the product of type C and D, time for machining becomes respectively 3x3 and x4. Thus, total time for all the 4 type of products for machining becomes x1 plus 1.5 x2 plus 3x3 plus x4, but it should not be exceeded the available 250 hours. Therefore, x1 plus 1.5 x2 plus 3x3 plus x4 should be less than or equal to 250, which we call constraint number 1. Similarly, for grinding, the constraint becomes 2x1 plus 2x2 plus 5x3 plus 2x4 less than equal to 80, constraint number 2. And for assembling, 5x1 plus 4x2 plus 6x3 plus 6x4 less than equal to 650, which would be constraint number 3. And for painting, 2x1 plus 3x2 plus 3x3 plus 3x4 less than equal to 400 becomes the constraint 4. The linear programming problem therefore can be put in the following mathematical format. Maximize profit Z equal to 20x1 plus 30x2 plus 25x3 plus 40x4 subject to constraints x1 plus 1.5 x2 plus 3x3 plus x4 less than equal to 250, 2x1 plus 2x2 plus 5x3 plus 2x4 less than equal to 80, 5x1 plus 4x2 plus 6x3 plus 6x4 less than equal to 650, and 2x1 plus 3x2 plus 3x3 plus 3x4 less than equal to 400, where x1 greater than or equal to 0, x2 greater than or equal to 0, x3 greater than or equal to 0, and x4 greater than or equal to 0. Let us see now example 2. A cold drink company has 2 bottling plants located at 2 different places. Each plant produces 3 different drinks P, Q and R. The capacities of 2 plants in number of bottles per day are as follows. Let us see in the slide. We have given the first column plant 1 and plant 2. In the next 3 column, we have given the product for P, Q and R. For plant 1, the product is 2000 for P, 1500 for Q and 2500 for R. For plant 2, 1500 for P, 1500 for Q and 5000 for R. A market indicates that during any particular month, there will be a demand of 25,000 bottles of P, 20,000 bottles of Q and 40,000 bottles of R. The operation cost per day of running plants are respectively 700 rupees and 500 rupees. How many days should the company run each plant during the month so that production cost is minimized while still meeting the market demand? Let us see how to formulate the problem. Let company should run plant 1 for x1 days and plant 2 for x2 days. Therefore, total cost for both the plants will be 700 x1 plus 500 x2, which is to be maximized. Now, to determine the constraint for product P, at plant 1, 2000 units can be produced per day. Therefore, in x1 days, 2000 x1 units can be produced. At plant 2, 1000 units can be produced per day. Therefore, in x2 days, 1000 into x2 units can be produced. Therefore, total production of type P becomes 2000 x1 plus 1000 x2. But demand of product type P is of 25,000 units, and therefore 2000 x1 plus 1000 x2 should be greater than or equal to 25,000. We call it constraint number 1. Now for product Q. At plant 1, 1500 units can be produced per day. Therefore, in x1 days, 1500 into x1 units can be produced. At plant 2, 1500 units can be produced per day. Therefore, in x2 days, 1500 x2 units can be produced. Therefore, total production of type Q becomes 1500 x1 plus 1500 x2, and therefore, the constraints becomes 1500 x1 plus 1500 x2 greater than or equal to 20,000. Constraint number 2. Similarly, we can get constraints for product R as 2500 x1, 5000 x2 greater than or equal to 40,000, and last x1 greater than or equal to 0, x2 greater than or equal to 0. Hence, the whole problem can be put in the following format: minimize z equal to 700 x1 plus 500 x2, subject to the constraints 2000 x1 plus 1000 x2 greater than or equal to 25,000, 1500 x1 plus 1500 x2 greater than or equal to 20,000, 2500 x1 plus 5000 x2 greater than or equal to 40,000, and x1 greater than or equal to 0, x2 greater than or equal to 0. Let us summarize the talk. Operations research is a new approach used in the scientific study for problem solving under the given constraints. It is useful to a decision maker to solve a complex problem which may not be possible to solve by any traditional methods. It is used in finance, purchasing, marketing, production management, research and development, LIC, and in many other areas. 3 types of methods are used to solve OR models: analytic method, numerical methods, and Monte Carlo methods. Thank you.